Okay, we have 60 minutes, and I see it's overwhelming to see so much people interested in the old stuff. It does not mean that you are looking old, as me, but it's so interesting that you are interested in, engine-related stuff, and the topic LOB data management is becoming more and more interesting for several reasons. And I want to show you some tricks and some bad and some good things how to handle them. But before we start with the session, first of all, a big shout out for the vendors. I think for the sponsors, and I think that you all know that without sponsors, these kind of events won't happen for that price. Okay, so these are the links for this session. You can make a photo. Yeah. The scripts and the slide decks are on my GitHub repository. I'm using a demo. Yeah, come in. Yeah, it's so good to see so much people coming in. I'm using a demo database, which is quite interesting for this because I don't like to work with small databases. This is, by the way, more fancy stuff for kindergarten. We want to work with big data and with big databases. So therefore, I've created my own database for this, and there are lots of millions of records in it. What I normally use when it comes to evolve workloads, to push some pressure on your SQL Server, use SQL Query Trace. I love this tool. It's absolutely perfect for this. And the last one, the Windows Admin Center, is more a little bit for monitoring. Oops, sorry. Oh, come on. You see, I'm nervous. Also, at the 10th time I'm here, I'm always nervous when I'm here. This is me. My name is Uwe Ricken. I'm from Germany. No worries. I don't do anything. Most important thing for you is, most important for you is my email address. So whenever you have questions related to engine related topics, just drop me an email. I'm really happy to answer this, and I promise I will answer every single question what's coming by email. The rest is a commercial thing, forget about this. So, and now we can start. Whew. We have 60 minutes and I need to be in time because my session is the last one before lunch. And everybody here who is not the first time here know about the problems when it comes to lunch. It's waiting. By the way, I have an interesting session about wait stats. I could use the lunch queue, for example, for this. So what we are going to do is, first of all, we need to talk about what LOB data is, why you should use this, how they are organized. This is an advanced session, so that means it is not about, hey, there is some LOB data, enjoy. We are going into the internals. I want to show you how these data get organized to get a deeper understanding why some techniques are completely wrong to do and why you should maybe change your strategy when it comes to LOB data. LOB data will be used in these modern times all the way. Who of you is dealing with JSON? Who is storing JSON in the database? I blame you. Yeah, or the same with XML, pictures. There are some nerdy applications out in the field. For example, they are storing documents in databases. Pictures, some smiling people and so on. And these are called LOB data. And I'm going to show you how LOB data are organized, what the difference between row overflow and LOB data. And then we come to the big problems, what we have. Problem with storage or with the storing LOB data. And this is a heavily demo-based session. I hope that you can, by the way, I sit down later on, yeah, if you don't see it now, don't worry, I will sit down. So, how are data stored in SQL Server? Let's go, first of all, to some fundamentals. When it comes to storing data, the good thing is everything is nearby the same. Every heap, every clustered index, non-clustered index is separate, is in a separate object storage. So that means all have the same internal structures. So when it comes to a table, every single table is based on at least one partition. These kind of partitions will then have two different, or can have two different types of data, what they store. We have the in-row data. You all know in-row data. That does mean the record will fit on one single data page, whatever size it is. It could be a small table, it could be a big table, whatever it is. When the row fits into one data page, it's called in-row data. We all know this. Then we come to the out-of-row data, the so-called row overflow data. This is the first challenge what you have. Normally you would say, oh, come on, how can this happen? Because one data page is only storing 8,060 bytes. And then the first question how could it be that one single row could exceed 8,060 bytes? Don't worry, the problem is not the database, it's the developers. They have so much fantasy when they're creating tables. And they have hundreds of columns in it, and when you add all the bits and bytes they have, you immediately, very fast, come to a size of more than 8,060 bytes. And then comes the hardcore part. It's data porn, I call it. It's LOB data. LOB data are a specific way of data. LOB data does mean that you store data which are way, way out of these 8K, or sometimes I see it could be even smaller than 8K. This is a curiosity. And LOB data, you all know it when you have, for example, varchar max attributes in your tables, or var binary data. Yeah. So we start with the row overflow data. The row overflow data stores variable length column. This can only happen if you have variable length columns in your table. As long as you use fixed length columns, which could be data types for numeric values for data, but also char or nchar, these are fixed length attributes. You cannot have tables when you only use these kinds of attributes, which is longer than 8,060 bytes, then you get an error. But as long as you're using varchar attributes, you can add as much columns as you want, 32,000. And if that doesn't fit, think about your quality as a database designer. Yeah. So the determining factor of whether a data fits on a data page or not is that keep always, please always now in mind. The row length itself controls whether you're talking about in-row or row overflow data. The row, not the data of one separate column. This is a really important thing. How full the regular page is into which SQL Server is trying to insert the new row is not, it doesn't matter. The important thing is the row length. SQL Server constructs a row as usual and stores some of its column as a row overflow only if the row itself needs more than these 8,060 bytes. And I'll show it in a demo later on. Here comes the overhead what you have to take when it comes to row overflow data. So let's say you have one record and the record exceeds the number of 8,060 bytes. What will happen? SQL Server must distribute the data over multiple data pages. And what SQL Server then is doing, it's constructing an overhead which has to be counted into your payload. What SQL Server is doing when it comes to a row which is longer than 8,060 bytes, SQL Server adds 24 bytes for a pointer which then points to the data which do not fit on the same page as the rest of the record. And that makes it expensive in two different ways. First of all, you have 24 more bytes on this record. Think big. Let's say you have a table with 30, or let's say with 100 million rows. Every single row is larger than 8,060 bytes. And now you have 24 bytes for every single row added on top of it. Plus, row overflow data will generate random access to a storage, because the data are not located in the page directly to the row. No, it could be anywhere on your storage. And that makes it expensive. Sorry, I need to go back one. The information what you get here is, let me be careful, I'm old. Oh. Here is the pointer. Here it stands where we find the rest of the record. Yeah. So this is a different page, different from the page we have here. The level, blah, blah, blah. The type 2 is standing for row overflow data. I skip this, it's not so important. My favorite. Let's do a demo for this and have fun. This is good for me. I was, last week I was in New York and I had jet lag, So in the morning, I've decided I had a stupid idea. My hotel was at the 42nd Street, and I decided to walk to Brooklyn Bridge. I feel it now. Okay, so here is my first demo. Very simple, very easy. Can everybody read this? Is it large enough for you? Yeah. I was checking it, and when I can read it, I definitely think that you can do this too. Okay, very simple, very clear. What I do is first of all, I create a table, and have a look, please, to the table here. The table can have, can have a size which is larger than 8060 bytes, because we have 8000 plus 256. This is the possible max length. Now I insert 20 rows into this, and here you can now see where my data are located. What you see here is my page ID. This is the data page where this record is on. And what we can see here very perfectly is that all of my records are on one single data page. That means that the single row is so small that we can store 20 rows on one data page. So the payload, 8060 bytes, is not full now that we do not generate a second page. Let's look into the page. Oh, stop, I need to, this is always the same. I need to copy the page and put it in. Let's have a look into this page. What you see now is the details of the page. And what's interesting for us is here, look to the free bytes. The free bytes does mean I have 20 files, 20 records stored, but now I have a free payload of 5,828 bytes. So this is the number of characters of information I can store on top of it on this page. Okay, 5,826. Remember this value, please. Here comes, first of all, here comes my first question. By the way, did I tell you that this is an interactive session? It's a Q&A. I question, you answer. Here is the first thing. I now insert a row. Look to the size of the record. It's 200 bytes for the C1 column and 5,460 bytes for the second one. So the total row has 5,660 bytes. Question to you. Will it be stored on the same data page? Who say you don't have to don't have to talk? Who say yes, it will? Oops. Who say no? Ah, super. Who say when Uwe is asking such silly questions, there must be a trap on it? Okay. I insert this row. Bam. It's in. And now let's check where the record is. By the way, the record is the number 20. This is this one here. And look to this. Oops. It's on the same page. The reason why it is on the same page is that we had enough space free for the whole record. And I can prove it by evidence when I look into the page information and, oops, sorry, wrong page. Yeah. I know. Oh, yeah, no. Oh, 1 second. Copy. But it's good because I see that you're paying attention to this. Okay, here we are. Free bytes is 140. Oops. Free bytes. I have 149 bytes more free. And now come the bad part. Look to this. I enlarge it because then you can read it better. Then there is no excuse for you. Oh, I didn't see the values. No idea. I insert the next row. The column C1 will have a total size of 100 bytes. And the second one is 8,000 bytes. So the whole row is now larger than 8,060 bytes. Will it be option A? The record will be stored on the same page. Who say, no, it must be yes? 1, 2, 3, super. Who will say, option B, no, this is way too much, it must now be on a new page? 1, 2, 3, 4, oh, way more. And who thinks about option C? I'm an idiot. Come on. So let's see what it is. I insert the row, bam, and now let's see where it is. And so, oh, yes. First of all, I have to run this query. So look to this. Oops, same page. And this is something what is really curious, isn't it? Hey, come on, we had over 8,000 bytes. So the record is so way too big for the 149 bytes, which will be free. But here comes the point. First thing, really important. The row size, and that is the most important part here, is bigger than 8,060 bytes. 8,000 plus the 100 is more than 8,060. Row overflow data will always concern row length, not what is on the page, row length. So now we are over 8,060 byte, and what will SQL Server then do when it comes to more row size than the 8,060? We split it. We put one of the columns to another page that the whole record can be stored. And what it's doing is, it's putting the 8,000, the column C2, on a new page. How much was the size of the column C1? 100 bytes. How much did we have free? 149. Bam, the record fits into the page. That's the point here. Plus the 24 bytes, by the way, for the pointer. So that's the reason why, and copy this. Oops. Oh, thick fingers and small keyboard. Doesn't fit really good. So let's look into this. I look into the page, and here is my free bytes. 6 bytes only. 100 is lost, 24 for the pointer, and a little bit of overhead for the row constructor. So, whoops, very, very clear. Now, I clear it, and we go into the second, because I have more than one demo for the row overflow. It's a really interesting thing. So, again, I create my table. Let's put an helping index on my data, and here again. This is my table. Now it's a little bit larger. Look to the C comment. This is the interesting attribute here. It's a varchar 8000. And trust me, lots of people are using this kind of data, 8000. And varchar 4000, varchar 8000. When I look in, I have one application, I was like this, said, gosh, no, that cannot be happening. You saw, let's say 15 to 20 columns. Believe me, the first one was an integer, identity. A good developer. The rest, all, really all, varchar 8000, varchar 8000, varchar 8000. They were storing zip, name, phone, everything in varchar 8000, varchar 8000. And they said, yeah, it's working. Yeah, I said, yeah, it's working, it's working. So now I create only an index, and here I insert now 1,000 rows into it. Native data, very small data, very keen data. And let's have a look to our index. There's a clustered index on it. Notice this. We have here 1,000 rows as so-called in-row data. So we have 1,000 rows as so-called in-row data. So that means every single row is less than 8,060 bytes. That's fine. We have 25 pages. We are using 15, and we have native data pages 13. That's it. 13 now. And now what I'm looking for, what I'm interested in is how many rows will fit into one data page. And this is the result. These are my pages, and you see that in average 78 rows will fit into one page, then it's full, bam, the next, the next, the next, the next. This is only preparation. This is like a magician trick, you know. I try to not show you what I'm doing behind. So, and here are my data. You see, here is my first customer, and when I go to 78, here it is, here is the jump. 78, and then we come to the next page. Proved it by evidence. Good. Let's start. I start my transaction. And this is important to show you, do it in a transaction, that I can show you what's going inside. Did I mention it's an advanced session? Okay, good. So what I'm doing is I'm doing an update. Let me explain to you what I do. You see here a CTE, which is now getting a record or a text which has a size of 5,714 bytes. And what I'm doing is I'm updating my record number 1. So in the comment, which is actually, let's say, 40, 50 characters in, I now push in 5,714 bytes. Question to you. Will the record be moved on a new page? Will we have so-called page split? Who say yes? Respect, respect, brave. Who say no? And who say, well, come on, it's option C. So how we can prove it very simple by looking into the transaction log, and that is looking really, really interesting. And what we see here, I need to go a little bit into detail. Look about the log record length. The log record length demonstrates how much bytes we are moving inside the transaction log. What is going on? The first thing what happens, is that I will lose, I put it right here. I'm so small that I can push it directly into the back. So let me go down. So the first thing what happens here is, look to this, the PFS page is a manager of all data pages in your database, of everything. Yeah. So the page free space got a record update. And when a page free space got an update, it could have two options. There is one record which changes in length, or there will be additional pages added to the object. And here it is. You see here that now SQL Server is formatting a page. It's the same as when you buy a ground and build your flat on it. That's the format. It's creating a data page for storing data. And then it comes with 7,000 bytes, whoa, that's really much, and pushing data into this newly created page. Only these 3 lines will guarantee that there has been data movement applied into the record. Let's go to the next. We have this horrible delete split. What is a delete split? A delete split does mean like this. Let's say you have one data page completely full. There is not even place for one more byte. And now a new record is coming and say, oh, I need to be inside this page. What happens then? SQL Server is putting half of the page, what is on this, and moves it over to a new page. And now we have 50% free. Whew. Here we have way more, by the way, free. 7,000 bytes. So then we modified the header. This is by creating the pointers forth and back. And then we insert a new information into the index structure, and we modify a column. Yeah, modify columns. And here you see the bytes, which are changed, which is an indicator for what. Uwe said that the text which I add is around 5,600 bytes in size. That's it. So what happened here? What SQL Server did was the following. The first thing is, Do you remember what I said the very first when it came to row overflow data? I said it is related to the length of the row, not of the data itself. Question: if this row where I added 5,700 bytes, is this row, only this row, longer now than 8,060 bytes? Never. So there could be no row overflow data for this row. And what we have is a typical normal page split. And I show it to you. We just go down, commit it, and now we check it. And what we see here, and this is very clear, here is the area for row overflow data. We do not store anything in row overflow data. Nothing. But we have one more data page. Okay, come down to this. Bam. I drop this. And the last row overflow. It's time. It's time enough. I got a message that the steaks are not ready yet. You can come in 45 minutes to lunch. Okay, so again, we create the table. Empty table. I put an index on it. It's always the same. And I put 1,000 rows into it. This is how my index looks like. It's the same as you have seen before. We have 13 pages. We have a clustered index on it. We have row overflow data, an area for row overflow data, which is actually not used. So now we see, I can skip this, it's okay. We have 78 rows. Trust me, it's the same structure. I begin my transaction. My transaction now is doing the following. Look to this statement, to the first statement here. I update my customers. I take my customer number 1 and I add, or I change the comment from approximately 30, 40, 50 bytes to 8,000 bytes. Question to you. Will this now force again a page split, that we move the data around? Who say option A? There was a no. That's the second question. Okay. Who think now the record will stay at the position where it is, and we create a new page just only for the comment? Raise your hands. At least one is correct. It's option B, and I show it to you. So I started my transaction. Did I? I don't know. However, so I update it. Bam. And now we look into the transaction. And this looks way maybe more complicated than the previous one, but trust me, it's so simple. So we, you see that there is a GAM information. GAM stands for Global Allocation Map. What we now have is we have definitely a new page in it, but we have a new data type, not data type, but a new storage type here in it. We modify the PFS. Let's jump over it and look to the fourth line, LOB format page. IAM. The IAM is the index allocation map. And every single index, every single type, whether it's in row, row overflow, or LOB data, will always have its own IAM data page. Always. So when we create a new IAM page, it does mean, oops, we have a new data part. And then we switch over it. Then you see that there will be a new context type, which maybe some of you have never seen before. It is called text mix. I don't know why Microsoft is doing it this way. I would name it vice versa, say mixed text, because we are mixing some parts of the records outside of the record. That's the mixed part. But they say, okay, no, text mix looks more interesting. So we format it, we insert rows, it's 108 bytes, but then the same row, we modify it and push 8,076 bytes into it. This is definitely the evidence that we have moved 8,000 bytes around. And last but not least, we changed the record itself. Why itself? Well, we need to have the pointer now to the page where we have the comment stored in. I commit it. 1. Okay, so do a checkpoint. Let's see where my data are. Remember, it was record number 1 which I have changed, and the record number 1 here, you can see it, it's on the same page as all the others. We do not move records, or we do not have any page splits here. I need to copy it. Don't forget it. So this is my structure, and look to this. Here are my row overflow data, and suddenly I have 9 pages, which are using 2 pages. One is the IAM page, and one is the pure data page where my comment is stored on. So now we look into this, and these are the type of data what we have here now. Look to this. Here is the new IAM page. Here is the so-called text mixed page. But Kay would say, oh, it's tall. It's a text mixed page. Looks funny. But have a look to this, where it is. Here is my record, let's say on this data page, 91,000. But the new one is on page 100,000. What does this mean? Think about this when you read your data. And every single time when a record gets read, it goes to the pointer, say, oops, I have to go to the extra page where my row overflow data is. And that is expensive. It's not in memory expensive. It's not, honestly, when people are saying, oh, it's expensive because of storage. Come on, this is bullshit. Because when we have the data in memory, what is the expensive part? It's not the memory, it's not the storage. We are dealing with really modern storage. We have flash disk all the time. So when I come to a customer, I just only have one customer who has spindle disks. But this customer is running a kiosk. You can beer and water by there, but high professional, they have flash disks. But what is expensive is the CPU, because it needs to address another area in the memory. And when it takes it 1,000,000 times, these are additional clock speeds, bip, 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 all the time. That makes it CPU incentive. So how does it look like? I go into this page, 1 second, here it is, copy, and now let's look into this page. By the way, this is the reason why it is an advanced session. I'm using DBCC page. In the early times, when I was young, that was an information for, oh, there is a professional sitting there and doing some demos. Yeah. The same as when you're now in a bar and you drop your Porsche key and to say, hey, baby, I'm driving a Porsche. And I can say, hey, I'm a data engineer, I'm using DBCC page. What do you think? What will happen better in a bar, huh? I think it's not the DBCC. Okay, so here we are. And this is our slot 0. No worry, I will increase it. Here we are. So, oh, we can see data. That's cool. We can see data. Wow. And when we look down, we see suddenly this one here. And what SQL Server want to tell us here is, oh, Uwe, I'm so sorry, but the comment cannot fit directly on the same page. If you want to read it, just go to this page. But what SQL Server has stored here is an additional 24 bytes to the record. It's clear we need the pointer. And the pointer consumes 24 bytes. And plus this 24 bytes and the hop to the next page, that makes row overflow data expensive. Know your data. And maybe you talk to the developers and maybe they will do it a little bit better afterwards. Or never. Okay, any questions so far? Demo is closed. So, short summary. Think, and that's really, really important. Row overflow data are not controlled by the amount of data you are storing, whether it fits on a page or not. It's controlled by the row size. When the row size exceeds 8,060 bytes, you generate row overflow data. No other reason. So here you see that's a 4,000. The record itself will never ever come over the 8,060. What will happen is that SQL Server will now create a page split. Page split does mean SQL Server must free the page that it can store the additional 4,000 bytes, And that does mean that we move the rest of the data to another page. Now we have the 4,000 bytes free, and then we add it to this page. Easy. But waste of memory, by the way. Waste of memory. You think about this, 4,000 bytes in a comment field, which nobody normally wants to access. Only, let's say, a few times, but you have to load them all into memory. Not a good idea. But trust me, LOB data become more harder than this one, more funny. So, here comes the next demo. What I showed you is when it comes to row overflow data, the row size exceeds to more than 8,060 bytes. This is a comment here. This is my statement. Then what happens is that SQL Server will add a pointer to the row, and it will not make place for the rest of the data, but it will store it on another data page, which costs you additional IOs. And that is the expensive part of row overflow data. So now it comes to the fun part, to the LOB data. Everybody of us wants to store pictures, documents, PDFs, whatever. No, fun fact, it's not. But what I see very, very often now in modern times is people are storing lots of JSON. JSON, XML, all these kind of data are normally stored in varchar max fields. And varchar max is the LOB data. Varchar and varchar, that's LOB data. In the previous times, before SQL 2005, we had these funny things like text and text or image. So, maybe better. So, but that was former times. Anybody of you using text in the application? Oh yeah, I see. You're doing it exactly like this. Oh yeah. Trust me, I see it all the time. The problem was back in 2000 that we had special functions to write data into this because they were specially handled. But with SQL 2005, SQL Server came with varchar and varchar max and var binary. And all the old stuff like end text and image should not be used. Should not. It does not mean it's. I think that the way how developer thinks, it's there. Why not use it? Yeah. So what you normally see is now in modern times n varchar max or var binary max. Whenever there is a max in it, is always does mean we're dealing with LOB data. Always. In that moment, row size is not important anymore. So, oh, a demo. That's fine. I'm surprised. Okay. Scenario number 1. Let's close the rest of it. Maybe you get nervous when you say, "Oh my goodness, there are so much tabs on. There must be very complicated." No, it's not. It's not. It's not. So it did LOB, yeah. So I go into my demo table and create a demo database, and I create again a table. In this table, have a look to this. I add a new column. It's called C company logo. I think you all know what I will store now in this. Okay, so I have a company logo. Then I create my key on it, my primary key. And now I'm doing this here. I insert into my table 1,000 rows, but I do not add a logo here. This attribute is empty. So now it looks like this. And I have to say it's lovely. We have 23 data pages which are in used 25, but 23 data pages. LOB data, don't worry about this. This is okay. That SQL Server has automatically reserved a space for possible LOB data. And we have row overflow data. Good. So now, when we look into the data, I go into this page. I told you that it is an advanced session because of DBCC page. Bam. So here we are. Here is my record, slot number 0. And here is my record. So you can see everything is perfectly stored in it. And my company logo, this is null. This is in all my rows null. And but the most important thing here is that you look to the record size, it's 193 bytes. Okay? So this is the average. All the rows will have the same, nearby the same. Okay. And here comes the point. I start my transaction. Let me tell you first what I'm doing. Really important here to understand when it comes to LOB data, because when people thinking about LOB data, they always think about big sized documents or something like this. Here, I now do the following. I have my record number 1, and I insert the company logo and have a look to the size. You need to trust me. The size of the data file which I insert now has 4,582 bytes. Question to you. Option A, the information or the picture will be stored with the record and we generate a page split. It's a LOB. Or is it option B? The record must stay, stop. Yeah. It will be stored as raw overflow, stupid. But okay, option A, what do you think? Will the record be stored on one single data page and it will generate a page split? Who say yes, option A? Okay, who say no, it's a LOB data. LOB data will not be stored with the record, it must be moved out. Super. The majority will do it like this. In Germany we say, ob du recht hast oder nicht, sagt dir gleich das Licht. So if you're right or wrong, will the light tell you. And here I didn't know, did I start the transaction? However, I can do it again, no problem. I can have as much transactions as I want. I have paid for this. So really, believe me, the picture is just only 4,000 bytes. And now I update it. Whoosh. Wow, that was quick. Yeah, and now look to this. And what you see, I only want to draw your attention to this. This is the only thing what is important. LOB delete split. What happened here? The row, including the picture, is on one data page. Why? Any idea? Thank you so much. Yeah, you were listening to me. I love it when people are listening to me. The row size is less than 8,060 bytes. You might mention, well, that cannot be true because you're talking about this, but when it comes to row overflow data, no, it's the same with LOB data. As long as the row size is less than this 8,060 bytes, it will fit on one data page. And then exactly this will happen. SQL Server say, oops, the record will fit to one page, move out the rest of it, that we can store this one record on this data page. What is now the drawback of this? We have 2 rows only, or maybe 1 row stored on this data page. There will never ever come new rows into this page. Lost for memory forever. Because no place for other rows. And whoops, I show you how this is looking like. Gang. Yeah, okay, now we finished. So here are my data, and you see, oops, there is no LOB data. Yeah? No LOB data, nothing is in here. And when we look into the pages, you see this. I changed number 1 here. So 78 were normally fitting into one page. So let's see where now was the break. Oh, here it is. With record number 9, that is the number of rows which are now on this page, and the rest has been moved over far away here. Far away. It's like little child in the back. Hey, daddy, mommy, how long will it take? You're sitting just 5 minutes driving. How long will it take? It's the same here. Say, yeah, we have to walk 40 more pages to the next side. And this is a jump forth and back. Not the best. So what is the lesson learned? Whether someone is talking about LOB data, and you say, oh yeah, LOB data, big, large data, It is not important whether it's defined as LOB data or not, as long as the rows, by default, will fit on one data page. The record will always be stored on this single data page, and it comes to the point that you will lose storage, lots of space, memory, and this is the second demo, because I have one more for you. Scenario number 2. That makes more fun. Do you enjoy so far what it's some new stuff for you? Hopefully, yes. I say, you could normally say, oh, come on, give me new stuff. That's old stuff. That's back from the 2000, what was it, 5. Since 2005, it's working like this. So I create my table again, hep. Here again, empty table with a clustered index on it. The reason I'm putting a clustered index on it is because Microsoft says. You see the funny part of this, yeah? Okay. Sorry, insert 1,000 rows. Promise me there will always be 78 rows on one page. Here are my data. And you can pretty clearly see, again, 23. Data pages, we are using 25 rows, but we do not have any LOB or row overflow data. Now, I start my transaction. Here comes the transaction. Now, the first record, the first company in the row was a small company. That's the reason why the logo was so small. Yeah, this one is one of the DAX 30 or the Fortune 500. They have a bigger logo in it. It's 475,000 bytes. I don't want to ask because I think that is really clear that it cannot fit on one data page. Okay, so I start my transaction. I update my customer number 1, and I make it quick, very simple. Here is my data, and you see, oh, what's going on here? Oh, they format pages. I wish that would be 100 euros, and I could, into my account, 100 and 100 and 100. No, this is the way how now the picture gets stored in your database. This is all called text mix page. And go, and lots of data. We are motivating, we are pushing data into this, and so on. And suddenly you see this here. Oops, what is this? Text tree. It's green politics? No. Think about this. A text mix page or a mix page will only store chunks of the pictures, of this picture. But now with LOB data, we need to have a controlling mechanism which say, okay, you first have to go to this one, and then to this, and then to this, and then to this, and then to this. Something which can never happen with row overflow data, because row overflow data will just only have a pointer to this one single column. Here, we do not talking about columns. We are talking about data chunks. And these data chunks must be controlled. Long story short, when I commit it, okay, you can now see that we have, funny, we have LOB data. That's what we want to have in our database. LOB data are there. We have, wow, we have 62 pages. This is nearby the size of my data, of my picture. Yeah. Oh, I'm so happy that we got it. And now what you can see is no page split. All 78 rows, all are on the same page as before. So we didn't move data. The only thing what we did was we added to the record number 1 24 bytes, and now it's pointing to where the picture is. And the picture is not just only on one page, it's on multiple pages. And that is for where the tree is. Let's have a look to this. Go into this. Blah, blah, blah. It was number 1. Number 1. Here it is. Level. Here. Oops, sorry. Here. And look to this. The 24 bytes. The 24 bytes is for the pointer. We had enough space on the page that we could add the 24 for this single record. And then the data are not there, but come on, hey. That's the reason why I hate the mouse. So here starts my record. It's on page 605,000. Hey, that's more far away. By the way, I've heard that for a good marriage, it's good that you both live in different houses. That's what we do. So, and my wife and me, we are married since 33 years. So, and now look to this. What I'm looking now into here is the, oh, what is wrong? Oh, yeah, sorry. Yeah. Thank you for this. So, now what you see here is very simple. Very, very simple. This is, let's say, the coordination picture, the coordination page. SQL Server moves over to read the picture. But when it comes to the picture, it say, well, okay, sorry, you have to walk through 60 pages. And you go first to this, and then to this, and this, and this, and this. This is how SQL Server is reading LOB data. And that's expensive. That's really expensive. Bless you. Next thing. I have so much super demos. So, organization of LOB data. Record 1, we added, when you add a picture, for example, here is 16 kilobytes in size, then SQL Server will add automatically a text tree page. What? When do I have to stop? At 1310, isn't it? 110? I need to speak a little bit smaller, faster. Okay, you see this text page, then it goes automatically, it's pointed to this, and it's very simple. And then we add the mixed pages, which are now controlled by this page, and then it moves over to this. But there are really drawbacks with this. Everybody did a picture. I see some people taking a picture. I hope you took a picture of this, not from me. I'm not so interesting. I'm old. And so here, let's go to this. Here, inserting LOB data. 10 minutes, I want to show you a few things. This is really crazy. Now I'm gonna simulate a workload. And this workload will do the following. I now add 1,000 rows, 1,000 customers into my table. And what I'm doing is here, I'm putting in a small blob-sized picture. Small does mean it is around 5 kilobytes. And now comes a really bad thing. I insert them. Oh, that was quick, right? This is only for a measure for me. You can see here it took 500 milliseconds. Really quick, or wasn't it? It was, yes, absolutely. By the way, did I tell you that I use 22 cores and use a flash storage for this laptop? It's a funny thing here. I love it. So, but now, you remember, 1,000 rows. 1,000 rows inserted, and look to this disaster here. Do we have LOB data? No. The reason is pretty simple. My picture is just only 5.5 kilobytes in size. It fits to one page. So that is the reason why we have, we have 1,000 data pages. Can you explain what happened here? What is the idea behind this? Yeah? Exactly. Applause to him. That's really cool. That's exactly the point. We have one picture which is in size 5.5 kilobytes. So there is one thing for guarantee. There could be not more than one single row on one data page. And see how this will work. Oops, we say. I do a statistics IO on, and I run this select. It is okay whether it's 1,000 or not, but look to the IO. Here, logical reads 1,006 pages. But there is another heavy, extreme heavy disaster. We are losing memory. Make a simple math. 5.5 kilobyte for the picture. Let's say 100 bytes for the rest of the record is 5.6 kilobytes. The rest, 2.5, will never ever be used anymore. And when you load data into memory, you do not load data, you're loading data pages. So that means you have lots of air in your memory. A good chance for Microsoft to increase their revenue, especially when it comes to cloud, because then you need more memory. And if you want to have more memory, what do you have to choose with memory? Cores. Hey, and anybody who was at the session from Edwin know Microsoft will be very happy about this. Even if we do not select the picture, here it is not in the select list. When I run this, there 1,000 pages. Funny. That's really cool. So let's stop this. Column store. The question was what was column store? The answer is I don't know actually. To be honest, I do not really know actually. I need to test it. But what I definitely know for sure is that a var binary cannot be that has not a good compression rate. Never ever. So it will be full, but it's segments. So if the LOB data are larger than these 8Ks. Now I take which one is 500 kilobytes, and you see, oops, that takes a little bit longer. Here we are. It's 1.1 seconds. Oh, 4 minutes to go. I need to hurry up. But now you can see pretty clear. I make it short, make it quick. You see, my data are now fitting perfectly into these pages, and my pictures are outsourced. Yeah? They need to work from different premises. And so how can we optimize this? So here we go. Normally, when this will be the final demo. What I do when it comes to LOB data, my recommendation is, first of all, put your LOB data on a separate file group. This is what I do all the time. Whenever it comes to LOB data, don't put it on the primary, because think of this. Think of RTO, recovery time objectives. I had such a case. I had one customer, they had a 10 terabyte database, but here comes the point. The pure data was around 300-400 gigabytes only. The rest was pictures, documents in Germany from health insurances. So what was the problem? When it crashes, we need to restore 10 terabyte of data. But what you can do is, when you have an enterprise edition, you can do piecemeal restore. First of all, put the primary online again and say, now you can work. But you cannot access the documents. And in the meantime, while they are working, you can now restore the documents. Pretty cool. So this is what I do. I make a new file group and add a new file into this. It's LOB data. So when you create your table, and by the way, this can only be done in the moment you create your table. You cannot change it afterwards. I do not know why, but that's Microsoft. So whenever you want to say, I want to have my LOB data text image on a different file group, then add it to your create table statement, say, okay, it should be on a different one. So this is what I did. Now I insert again small LOB data. Oh yeah. Ooh, that was quick. Ooh, oh yeah. But again, 460 milliseconds. But the problem is, shit, we have the same problem as before. We have created a file group. I've created a file, but nothing did work. The reason is, by default, LOB data will be stored as normal data. What you must do is this. Here are my data. I did it, blah, blah. I create again my table. And then, whenever it comes to LOB data, second, really important thing is, when you know that your LOB data will permanently be larger than these 8Ks, PDFs, something like this, please use this option, SP table option, and force Microsoft to, whenever it comes to LOB data, to put it on the dedicated LOB area. This is this SP table option. I put it in now, whoop. I run exactly the same workload, small pictures, same. But now, It's perfect. Really? Oh, stop! They said stop, stop. Okay, then I said stop. Huge negative impacts, slow queries, yes, because low row counts, blah, 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 effects on page density, you know what I was talking about. And I need to say thank you so much, dziękuję bardzo, for being in my session.